Hello everyone and welcome back in a new video. My name is Wahid Anwar, and in this video we are going to explore some of the most important estimation techniques in project management. Okay, so estimation is at the heart of every successful project. It helps us to predict the cost, time, and resources so we can plan with the confidence. Okay, so as you know, no single method works for all the situation. So that's why project managers rely on different techniques depending on the stage of project, then the data available, and then you can say level of the uncertainty. Okay, so in this video, I will break down six powerful estimation methods like expert judgment, analogous estimation, parametric estimation, three-point estimation, bottom-up estimation, and reverse analysis. Okay, so each method has its own strength, limitations, and best use scenarios. So by the end of this video, you will have a clear understanding of how and when to apply each one to make your project plans more accurate and reliable. So let's start. Okay, so first we have schedule estimation methods in project management. Here you can see we have here the techniques used to predict the duration of the project task or activities. It helps to create realistic project timeline and schedule. Then it supports effective resource allocation and planning. Okay, so it reduces the uncertainty or risk related to project delays and can be based on experience and historical data, or you can say statistical analysis. Okay, the first you can say technique or method that is the expert judgment. So actually, this, in this method, we rely on the experience and knowledge of the people who have worked on a similar projects before. So these expert, maybe project manager, project engineer, or specialist who know the type of work very well. Okay, so actually, their input is very valuable because they can give a realistic estimation based on their past experience. So, however, we should not just depend on one person's opinion. So, the best practice is to gather input from the multiple experts, then compare their reviews, and then finalize the estimation. Okay, so this method is especially helpful in the early stage of the project when we may not have complete data available. But one thing to remember is that expert judgment can be sometimes be subjective. So it is better to support it with data if possible. So let's see what we have here in the under definition. So here you can see relies on the experienced professionals' knowledge and how it works. Expert gives the estimates based on the past projects. Okay, so when to use new oblique, you can see the unique projects with the little data. Okay, so when you will have not enough data, so that time you can use this technique. Okay, so we have here the example, senior planner estimates the turnover excavation equal to 12 months based on three similar past projects. Okay, so I hope this is clear. So next I have added here the references from the different books so you can check. Okay, so I hope this is clear. Now move next. So second we have analogous estimation. So actually, in this method, we use information from the previous projects to estimate our current project. If the past project was similar in size, scope, or you can say complexity, so then we can use that as a reference point. Okay, But this method is usually faster and less detailed because we don't go into, you can say, very every small activity. Okay, so that's why it's often used in the early planning stage. So the main, you can say, benefit is the speed, but the accuracy depends on how closely the past project matches with the current project. Okay, so actually, this and so analogous estimation is like saying, you can say, the product is similar to that one, so it should be, or you can say it will take around the same cost or durations. But if the product are, you can say, very different, so the estimation may not be reliable. Okay, so be careful. So let's see what we have here in the definition. Use duration cost from past similar products. Okay, so how it works by comparison with the historical data, when to use early stage planning, feasibility studies. Okay, so then example, a previous bridge took 18 months, a new bridge similar size estimated at the 17 to 19 months. Okay, so I hope this is clear. Okay, so number third, we have parametric estimation. Actually, this method use you can say, mathematical formulas and data to calculate the estimation. Okay, so here you can see under the definition, use mathematical model, rate multiply by quantity. Then how it works: apply productivity divided by cost rate per unit. Then when to use repetitive work with the reliable data. Okay, example, we have here 5 kilometer of road multiplied by 2 months. Then you can see divided by equal to kilometers, 10 months. Okay, so let me add one more example here. If we know the cost or a time per unit of the work, so we multiply it by number of units in the project. Okay, so parametric estimation is very useful when the project has the repetitive task or measurable quantities. So the results are usually more accurate than analogous estimation because it is based on the actual data and not just assumptions. So you can say, actually, you, you can say that if the unit rates are wrong, so the whole estimation definitely will also wrong. So this method is, can say, scientific, but it depends heavily on the quantity of the input data. So that's why be careful. You should have a accurate the units and productivity rates and everything. I mean to say, the data, the required data to calculate the parametric estimation for your project. So next, number four, we have 3 point estimation. Actually, in this method, we do not, uh, you can say, just give one number. Instead, we give three possible values: the optimistic estimate, then the most likely estimate, and then the pessimistic estimate. Then we take an average using a formula to get the final results. Okay, so this method is very useful when there is uncertainty or risk, you can say, will have. So it allows us to consider both the best case and worst case scenarios instead of just guessing one number. Okay, so by doing this, our estimates become more balanced and realistic, and it also helps us to prepare for possibility delays or challenges in the project. Okay, so here we have the definition: consider optimistic, most likely, then pessimistic. So how it works per formula. Okay, you can see here: optimistic plus 4 into most likely plus pessimistic divided by 6. high uncertainty and risk. So next we have here the example. You can see software testing, optimistic 8 days, then most likely 12 days, then pessimistic 20 days. So accepted, here we have the calculation here, so 12.7 days. Okay, so here we have the estimation example. You can also calculate 8 into 4, there will be sorry 4 12 into 4, there will be 48. 8, then 48, then plus 20 divided by 6. Okay, so you can verify using your own calculator. Okay, so I hope this is clear. So now move next. After that, we have bottom up estimation. Actually, this method is very detailed and usually you can say the most accurate method. So we break the project into very small tasks, estimate each one separately, and then add them all together to get the total estimation or estimate. Okay. Here you can see I have just added a very simple example work breakdown structure of a example. We have here the project deliverables, and then here we have the task. So we will calculate from the task. Okay, and it will be summarized here, or you can say we have on the top we will have cumulative numbers. Okay, so actually it takes more time to prepare because we need to analyze every activity in detail, and you can say the advantage of this estimation is that the result will be very reliable. So this method is mostly used when the project scope is clear and we know exactly what need to be done. Okay, so here you can see we have the definition: estimate each small task, then sum up. Here you can see. So how it works: breakdown WBS, estimate details, aggregates, then when to use, scope well defined. Okay, so example: building flow estimates. So 5 days forming plus 3 days wiring, then 2 days finishing equal to 10 days. So this is very simple example. So bottom up estimation is detailed, time consuming, and you can say most accurate method among all. So this is very useful. Okay, so number six, we have reserve analysis. So actually, in this method, we add extra time or cost, which we call contingency, or you can say buffer, to deal with the risk and uncertainties. Okay, so projects always face issues like weather changes, material delays, or technical problems. So by keeping some reserve, we make the plan more realistic and safe. So the amount of reserve depends on the level of risk in the project. So high risk projects need more buffer, while low risk projects may need less. Okay, so this method, the reminds us that no plan is perfect and we must prepare for the unexpected things. Okay, so that's why reserve analysis is very important for practical project management. Okay, so now let's take the overview for definition as contingency for risky and oblique uncertainty. How it works: identify risk, assign buffer time, then when to use complex or risk uh, the risk prone projects. Okay, so add 15 days weather buffer in the monsoon season. So I hope this example is clear, and reserve analysis technique or method is clear for estimation. So we have now explored six estimation techniques that every project manager should know, from the quick insights of expert judgment and analogous estimation to the data driven accuracy of parametric estimation and the balanced approach of 3 point estimation, to the detailed reliability of bottom up estimation, and finally practicality of reserve analysis. So each method plays, an important role in project planning. Okay, so remember, the real skill is not just knowing these methods, but choosing the right one at the right time, or you can say even combining them for the best results. Okay, so estimation will never be perfect, but with these techniques, your plans will be more realistic, reliable, and you can say resilient against uncertainty. So I hope everything is clear. So thank you so much for watching this video. See you in the next video.